This vehicle is attempting to access the base through the smart gate. When the driver fails the hand scanner, an alarm is generated and access is denied. This system can be immediately configured to meet force protection condition requirements by turning on or off selected identification technologies.
A second part of scenario number 2 is a contractor gate operation. What we're trying to do is detect large vehicles laden with explosives. We're using a system developed by SAIC called VACIS, Vehicle and Cargo Inspection System. VACIS gives us a gamma ray image of what's inside that vehicle.
What we're looking at on the screen are density variations. For example, here, right in the center of this container, we have a very dense object that doesn't match the rest of the cargo.
Scenario number 3 is a flight line alert area scenario. The Air Force has asked us to demonstrate the ability to detect, assess, and put extra layers of detection around critical resources such as a flight line alert area, a fighter alert area, presidential support aircraft, and other significant high-value Air Force assets. This is the next generation of video motion detection systems.
Instead of requiring an operator sitting there looking at each monitor, we've got software that's doing that 24 hours a day.
Coupled with a layered approach using TMPS. That sensor data will be fed through the annunciator to the BDOC, the Base Defense Operations Center, where the controller will get a signal that something's occurred.
An intruder attempts to access the protected flight line. The video motion detection software developed by iNetCam alerts to the initial intrusion and sends an alarm. A second line of detection, consisting of the Tactical Microwave Portable Sensors, TMPS, by Perimeter Products, activates and sends an additional alarm on the intrusion. A response team is then dispatched to apprehend the intruder.
In this case, we are demonstrating a number of new technologies in a layered approach to provide defense in depth of our weapons storage areas. The first piece that we will use is a man-trap automated entry system. This system combines 3 different phenomenologies: a card swipe, hand geometry reader, and a facial recognition capability.
The first biometric is hand geometry. The users have to together pass hand geometry, and they step inside the portal and they have to pass face recognition. He fails, and you can see on the screens that they're not accepted and not allowed in. Neither door opens.
The intrusion piece of this scenario will start at about 400 meters from the perimeter fence. This will be done with sensor phenomenologies, the first being an ARS sensor, ARSS, developed by Telephonics.
It'll detect the intruders at a large standoff distance.
We're using the ARSS in combination with a PSRS, which is also a short-range ground surveillance radar.
That has a 300-meter range, so it still pushes the defense area well outside the perimeter.
The PSRS will relay its information through the Vindicator annunciator to the Wide Area Surveillance Thermal Imager, which has a new capability in Octec software, which allows us to track and identify threats as they approach.
Closer in yet, there's the Cupid sensor. That has a tunable range from 30 to 90 meters.
The final piece that we have added to this scenario is MDARS.
The Mobile Detection Assessment and Response System, with its intrusion detection systems and its camera systems, is being used in this exercise as a response to an intrusion that's been detected by other sensors.
Far outside the perimeter of the weapons storage area, the advanced radar surveillance system produced by Telephonics detects and tracks an intruder. The ARSS automatically cues the wide area surveillance thermal imager, and the intruder is tracked using the adept video tracking software developed by Octec. As the intruder closes in on the facility, the layered sensors are activated. Perimeter Surveillance Radar System, PSRS, by SensorTech, and the Quick Reaction Perimeter Intrusion Detection Sensor, CUPIDS, by Curtiss-Wright. Finally, the Mobile Detection and Response System, MDARS, is dispatched to intercept and assess the intruder. This scenario also demonstrates the integration of the Vindicator Smart Annunciator into the command and control system.
The most important part of all of this is the integration of these technologies into a command and control network that will give our forces much better visibility into what's happening out at the perimeter, inside the storage areas, on the flight line. And that's what we do best. We have integrated this system with a true command and control system that gives the defenders immediate information, immediate data, immediate video feed from a variety of sources, and gives them an accurate picture of what's happening on the ground. At the end of the day, what we have done is put together the best of breed capabilities in the security world. We've added integrated C2 situational awareness, secure wireless comm to give our end users full dimensional protection.
This Smart Defender demonstration in December of 2002 by Northrop Grumman Mission Systems pulled together the best and brightest of legacy, new, and emerging force protection technologies. This team of 23 companies planned, developed, integrated, and demonstrated in less than 90 days a true leap ahead in capabilities to support the warfighter, allowing security forces to see first, understand first, and act first.